Alright, so last time we were in here, we were talking about addition and subtraction of fractions. And you need to remember that in order to add and subtract fractions, you gotta have a common denominator. So we started working with fractions that already had a common denominator. And if that's the case, then all you're going to do is combine your numerators, put it over one fraction, factor if possible, and then reduce. But if you don't have a common denominator, then of course you have to find a common denominator. And we started talking about that, and that brings us here. Now, anytime you see a rational expression and one of them is not a fraction, go ahead and make it into a fraction. Okay? So, for example, you have this 2. Go ahead and put it over 1. And so, your common denominator here, remember you have to use everything once and only once. So, the common denominator is going to be x plus 4 for both of these. Well, if that is your common denominator, look, this first fraction, the denominator didn't change from here to here. So the numerator is not going to change either. But from here, this denominator, to here, the x plus 4, that's what did change. And so we're going to have to multiply the top and the bottom by that x plus 4. So, 1 times x plus 4, of course, we've already got it. But then 2 times x plus 4, we're going to have 2x plus 8. Now what we're going to do, since we have a common denominator, we can make one fraction over that common denominator, and we're going to combine the numerators. So we have 7x minus 2x, which is going to be 5x. And then minus an 8, which is going to be a negative 8. From here, look to see if you can factor. Nothing's going to factor, so nothing's going to reduce, so that's going to be your answer. Alright, so that kind of gets us back in the swing of things. What I want you to do now is I want you to look in your books on page 181. And if you don't have a book, then you can get in a group with somebody and look with them. But in your books on page 181, I want you to look at number 68. And I want you to read through number 68 because it's going to explain to you what's going on this second problem. So, on page 181, number 68, it says, consider the addition problem. Well, our problem is subtraction, but it's the same concept, okay? It says, consider the addition problem. And what I want you to do is I want you to look at that problem and look at the denominators. What do you notice? They're opposite. They're backwards from each other. The first one you have an x minus 2, and in the next one you have a 2 minus x. This is going to be an easy fix. And this problem, what I like, is it shows you the y. And once we know the y, we can just do the shortcut. Okay, so it says, note that the denominators are opposite of each other. If the property a over negative b is the same as the negative a over b is applied to the second fraction, what you're going to get is this. Now watch, this is the step. You have 5 over 2 minus x, which is our original problem. And then basically what we're going to do is factor out a negative 1, or actually apply that negative 1 property. And so now what happens is it changes that denominator around. Your negative x goes to a positive x, and your positive 2 goes to a negative 2. And that allows us to just turn that whole entire denominator around. And so then it turns our problem into 8, from your original problem, 8 over x minus 2 plus 5 over 2 minus x, 2. And look at the difference here. Notice you went from an addition problem to a subtraction problem, and your denominators are the same. Okay? So what we're going to do, every time you see a denominator that are opposites of each other, what we're going to do is we're basically going to factor out a negative 1 and use that negative 1 property. And watch this. If you have a subtraction problem, it's going to turn into an addition problem. So we're going to have 10 over a minus 9 plus 5 over a minus 9. And again, all we've done is we factored out a negative 1 here. Well, if you multiply negative times a negative, what do you get? Negative times a negative is where that positive comes from. Okay? But if you factor out a negative 1, what you get is negative 9 plus a. Well, if we write it in descending order, you can see that your denominators are the same. And then if you, like I said, if you multiply negative times negative, you're going to get a plus. So, if you see a problem like this, and we're going to look at well, in your book on page 181, number 68, look down there where it says all those, A through F. The problem with those, A through F, is your denominators are opposite. Every single one of those. All you would need to do, for example, letter A, it's an addition problem. You're going to change it to a subtraction sign and make your denominators the same. For letter C, you're going to change it to an addition problem and make your denominators the same. All you're doing literally is taking an addition problem, making it into a subtraction problem, and making your denominators the same. And the whole reason is because of that negative 1 property. Now that we have a common denominator, we're just going to put our numerators together over that common denominator. And I want to keep this. Oh. So you have 15 over a minus 9. Now, a question that you need to ask yourself, and this is a reminder from last week, can I reduce the 15 and the 9 by 3? Can I reduce the 15 and the 9 by 3? Why? That 9 is involved in a group. The only way that you can cancel a group is if there's another group just like it somewhere. So that 15 and the 9 will not reduce because that 9 belongs to that A. So you can't pick things apart like that. So that's right there is going to be your answer. Okay. So now, let's go into 4.4. The only difference, okay, the only difference between 4.3 and 4.4 is that in 4.4, in order to find your common denominator, you're going to have to factor first. You're going to have to factor your denominators first. So, for example, look at this first fraction right here. Do you see what I can do? Yeah. You can factor out an x. So that's going to turn into 8 over x times x minus 4 plus 2 over x. Now, let's remember how to find that common denominator. To find the common denominator of a rational expression, this is what I'm going to ask you to do. Write down everything that you see in common first. Any factor that you see in common with both fractions. X. And it's going to be this x and this x. They're already in common. So write down anything you see that's in common and then turn around and write down anything that's not in common. And that's going to be your common denominator. Okay, so let's find our new numerators. Here's our new factored problem. So from this denominator to this one, nothing changed. So the numerator's not going to change. But from here to here, I multiplied by an x minus 4. So what's different from this denominator to this denominator is the x minus 4. So I'm going to have to multiply my numerator times that exact same thing. So we're going to get 2x minus 8. Now that I have a common denominator, we're going to make one fraction over that common denominator. And let's combine the numerators. And let's go ahead and get it in descending order. So the 2x is going to come first. And then 8 plus a negative 8 is just going to go to 0. So your numerator, those just cancel out. 8 minus 8. Now, can we reduce anything? What? Okay. We can reduce this x with this x. Okay? Reason being is because this x it's a factor. It does not belong to this group. So the question is, can I reduce this 2 with this 4? No, because that 4 does belong to that group. So your answer is going to be 2 over x minus 4. That is going to be your answer. All right, let's try again. Remember, we're going to factor the denominators only. Factor your denominators if possible. Well, which means we're going to leave our numerators alone. I know that a 2 is going to come out of there, but it's not going to help me to factor it out initially. So just leave the numerators alone, and let's factor the denominators. A squared minus 1 is going to go to a plus 1 and a minus 1. How do I know that? That's the difference in 2 squares pattern. It's memorization. You learned that in chapter 3. We're supposed to learn it in chapter 3. Plus 5 over a minus 1. Okay, let's think about what the common denominator is. What do these two fractions already have in common as far as the denominator is concerned? An a minus 1 group. That's already in common, so of course it has to be part of your common denominator. What's not in common? The a plus 1. So there's your common denominator. So let's work on making our new fractions, and it doesn't matter if you put plus or minus first. Okay, so let's make our new fraction for the first one initially. What's different from here to here? Nothing. Absolutely nothing. So the numerator is going to be the same as well. What's different from our second fraction to our new second fraction? A plus 1. So we need to multiply that top by a plus 1. So we're going to get a 5a plus 5. All right, now we have a common denominator. Let's make one fraction. Once you get your common denominator in your new numerators, you can make your one fraction. Combine like terms on top. So 6a plus 5a is going to be 11a. And 4 and 5 is going to be 9. Okay.
Does it matter if you do a minus 1 first or second?
Doesn't matter. All right, so here, what you're going to do is you're going to look to see if anything in the top will factor. It will not. So that's going to be your answer. If it would factor, though, I do want you to factor it. Okay, so we're going to factor at the beginning, and we're going to factor at the end. Don't forget that. Okay. So, for this one, I'll do one more with you. A squared minus 4, that's going to go into a plus 2 times a minus 2 minus 3 over a plus 2. That won't factor. So what's your common denominator going to be? Yep. What's already in common is an a plus 2, and then what's not in common is a minus 2. Okay, so your first fraction is not going to change. Your second fraction, however, we need to multiply by what's different, which is the a minus 2. Why did I change that to a plus sign? Alright, so we're going to have 3a minus 6. Make one fraction. And combine your a's. So 1a minus 3a is going to be a negative 2a. And then minus a negative 6 is going to be a plus 6. Now here, you can factor out a negative 2, and you're going to get a minus 3. So the question is, will anything reduce? It will factor, but will it reduce? No. It will factor, but it won't reduce. So that's going to be your answer. So just remember, look to factor at the beginning and look to factor at the end. I factored out a negative 2. I took negative 2a plus 6, and I factored out a negative 2, which means basically I'm going to divide each one of these by a negative 2. So it's going to give me a minus 3. That's chapter 3, factoring. Okay, let's try this one. Your first move is to factor your denominators. Your first move is to factor those denominators. So the numerator is going to stay the same right now. n squared plus 6n plus 5. You have a trinomial. Your leading coefficient's 1. What will this factor into? Very good. N plus 1 and n plus 5. Okay, let's work on the next one. You have a trinomial. Your leading coefficient's 1. What's this going to factor into? N plus 1 and n minus 8. Very good. Okay, now, let's find out what our common denominator is. Do you see something that's already in common with these denominators? N plus 1. What's not in common? And that is your whole entire common denominator. Okay, so now we need to work on our numerators. We haven't touched them yet. What's different from this denominator to this one? What's different from your first denominator to this one? The n minus 8. So we're going to have to multiply by n minus 8. So 3n times n is going to be 3n squared. 3n times negative 8 is going to be negative 24n. What's different from this denominator to this denominator? N plus 5. So we're going to have to multiply that top times that n plus 5. So if we distribute, we're going to get 4n plus 20. Now that we have a common denominator, we can make one fraction. Alright, so let's go descending order. We have 3n squared, just combining the numerators. Negative 24n and 4n is going to be negative 20n, and then you have a plus 20. Okay, now, let's try to factor that numerator. We have 3n squared minus 20n plus 20. It's a trinomial. Your leading coefficient is 3, so for most of us, that would be bottoms up. So we're going to have n squared minus 20n plus 60. Is there anything we can multiply together to get 60, but add together to get negative 20? Grab your calculator. Since there's nothing that we can multiply together to get 60, but add together to get 20, that's going to be your answer. Alright, and so since it won't factor, it certainly won't reduce. This is the never-ending problem. This one's so much fun. I love this problem. Watch this. Your first one, you have x to the fourth minus 1. Let's go off to the side and factor this. It's the difference of two squares. So we're going to have x squared plus 1 and x squared minus 1. Now the x squared plus 1 is prime, but the x squared minus 1 will go again into x plus 1 and x minus 1. So this denominator is going to go into x squared plus 1. And we did this problem like three or four times in chapter 3. Alright. This one, the one in the middle, that's the difference of two squares. We've already done it. It's going to be x plus 1 times x minus 1. And then the last one, that denominator will not factor. Okay, I guess we need to... Let's make our new numerators while we're at it. Okay, so can you tell me what the common denominator is going to be? What's already in common with all three fractions? X minus 1. And then what's not in common is the x plus 1 and the x squared plus 1. All of that is going to be your common denominator. Okay. So let's write all of these over that common denominator. A lot of writing. Did anything change from the old fraction to the new fraction? Did anything change in the denominator from here to here? No. So your numerator is going to stay the same. What changed if I write the common denominator here? What changed? The x squared plus 1. It's right here. That's what's new. So we're going to have to multiply this x times x squared plus 1. Distributive property x times x squared is going to be x to the third plus x. Okay, let's write the common denominator one more time and figure out what's different from the old denominator here to this. What's different from the old denominator to your new common denominator? Okay, and let's use a little bit of common sense here. This is 1 times all this. So 1 times all this is all this, right? So let's go ahead and pull this out. If we go off to the side again and we multiply x squared plus 1 times x plus 1, x squared times x is going to be x to the third. X squared times 1 is going to be x squared. 1 times x is going to be x. That looks like a 1. And 1 times 1 is going to be 1. So we get x to the third plus x squared plus x plus 1. Now that we have our common denominator, let's make one fraction. And combine those numerators. Let's go with descending order. So let's look at x to the third. Do you see another x to the third? Right here. So x to the third minus x to the third. What happens? They go away. Now let's go with x squared. We have 2x squared. We don't have any here, but we have 1 here. So 2x squared minus 1x squared is going to give us an x squared. Alright, now let's go with the x's. You have x minus x. What happens? Yep. And then you have minus 1. Minus 1. Okay? So, going through the steps one more time. You factor at the beginning. Factor your denominator. Find your common denominator. Make your new numerators. And then you're going to make one fraction with that common denominator. Then, what you need to do is you need to factor the numerator. So, we're going to have x plus 1 times x minus 1 over your common denominator. And you can see, now be careful with this, okay? X plus 1, x plus 1 cancels. X minus 1 and x minus 1 cancels. What are you left with on top? Please don't forget that. Don't tell me that your answer is x squared plus 1, because it's not. You want Chloe? This one? You got it? Okay. Anything else? Okay, so before we go there, alright, I will tell you, this will take practice. There's a lot of steps, because some of these, for example, on your test, well, let's just look at your study guide on page, well, let's just look at page 218. And look at number 11 and number 12, Bailey. Number 11 and number 12 on page 218. If I put those two on the test, would you know what to do? Because number 11, you don't have to factor before you find the common denominator. There's nothing to factor. So you wouldn't have to factor there, but look at number 12. Number 12 is exactly like number 1 over there on the board. You would have to factor that one before you find the common denominator. So make sure you understand that on your test. Your step number 1 is to factor the denominator if possible when you're doing addition and subtraction. It's not always possible, so make sure you're aware of that. Also, on number 5, would you find a common denominator on number 5? Why? It's multiplication. Multiplication and division, you do not need a common denominator, so that'll save you a little bit of time right there. Okay? Only addition and subtraction do you need that common denominator. Look at number 13. You would need to factor first. Factor that denominator first. Okay, so now let's go into complex fractions. And you already know how to do this, so this is going to be a little bit of a breather for you. This will be a little bit easier for you. When you see a fraction within a fraction, in other words, here you have your numerator is a fraction and your denominator is a fraction. So when you have a fraction within a fraction, or in our purposes, you have a fraction divided by another fraction, because that's what this is. This is a division problem. If I wanted to write this like we're used to seeing it, that would say 4 over x divided by 2 over xy. Now do you know what to do? Keep, change, flip. Okay? And that's all a complex fraction is. It's a fraction divided by another fraction. And you already know how to deal with that. You already know how to deal with that. So, here are your steps. It does get a little bit harder than this, but not that bad. To simplify a complex fraction, the first thing you're going to do is simplify the numerator and the denominator, if possible. If possible. Then you're going to rewrite your complex fraction as a division problem if you want to. I'm going to show you how to do this 2 different ways. And then you're going to go back to your rules for dividing, which we did in 4.2. That was last week. Okay? So, let's look at that first problem. Again, the easiest thing to do is to write it in something that's familiar to you. Instead of writing it as a complex fraction, write it as a division problem. So you're going to have 4 over x divided by 2 over xy. And then remember, instead of dividing, you have to keep, change, flip. Keep, change, flip. So we're going to keep the first one as is. Change division to what? Multiplication. And then flip that second fraction. Now notice I haven't factored at all. These are monomials. You can't factor monomials. So since you can't factor, you can just start canceling out. What do you see that will cancel? The x's and? Good. So if we multiply straight across, what we're going to get is basically just a 2 times y, which is 2y. Okay? So if you have monomials, it's as easy as that. You're going back to what you did in 4.2, keep, change, flip, cancel where you can, so on and so forth. Now, look at the one on the bottom. This one's not so easy, because this one has addition, subtraction, and division in it, all in one problem. So I can test you on many, many, many objectives in just this one problem. Okay? Now, what we're going to do is we're going to write it with common denominators first. I think I want that to be the first step. So we're going to simplify your numerator. So we're just going to focus on this right here. How would you add 3 over x plus 2 over y? What do you need? What is the common denominator? Good job. So that 3 over x is going to turn into what? 3y over xy. And that 2 over y is going to turn into what? 2x over xy. Good. Okay, so we have our numerator. with the common denominator. Now, let's deal with the denominator. What is the common denominator for those bottom two fractions? Good job. XY squared. So the left side numerator is going to turn into 5y squared. And the right side numerator is going to turn into 6x. Okay. So let's make this into one fraction over one fraction by combining your numerators, all right? So we're going to go descending order. So we're going to have 2x plus 3y over xy all over descending order, negative 6x plus 5y squared over xy squared. Now don't reduce anything here, because if you do, it's going to take you right back to where you started from. Okay? Some people want to cancel out the x's and the y's and all that. Not here. Okay. So, let's write it how we know, as a basic division problem. And if you want to skip this step and go ahead and do keep, change, flip, you can. Can I reduce anything at this point? The way the problem is written right now, can I reduce? No. No. For the same reason that I couldn't reduce here. I have a division problem. You can't reduce in a division problem. Keep, change, flip. So if I keep, change, flip, I'm going to have 2x plus 3y over xy. Change division to multiplication, and then I'm going to have xy squared over negative 6x plus 5y squared. Look to see if anything will factor. Nothing will. So you're going to reduce. What do you see that will reduce? This x with this x, and this y with one of those. So at this point, what you have is y times 2x plus 3 over 1 times negative 6x plus 5y squared. And that's as simplified as it gets. That's all you can do. It is. Thank you. All right, let's try this again. This is one way of doing this, writing it as a division problem. Now, when you get into higher level maths, really and truly we don't like doing all this. So, there is somewhat of a shortcut, and I call this skin over guts. It's called skin over guts because your skin is on the outside and it goes over your guts, right? Skin over guts. So skin is the outside. So what you're going to do is you're going to multiply, but not really, your skin over your guts. And it just keeps you from having to write, keep, change, flip, and all this, that, and the other. Skin over guts. Now, let's simplify. We can go ahead and multiply these two together. So we're going to have 15xy and 60y. Do you see what we'll reduce? 15 once will go into 60 4 times, and the two y's. And so you're going to be left with x over 4. Again, you can do the keep, change, flip like we did on the previous slide, or you can just remember skin over guts. If you take me for 112, calculus, 113, whatever, I'll do skin over guts. That's just what we do. It's just easier. All right, so here, let's go again. Before you do skin over guts, you have to have one fraction over one fraction. Okay, right now I have two fractions over two fractions, and that's just not going to get it. You have to have one fraction over one fraction. So let's find the common denominator. So you do have to go through all that. AB squared is going to be the common denominator. So on the left, it's going to be a 4b, and on the right, it's going to be a 3a. And I know that that's still new to you, so make sure you practice that. Common denominators, AB. We did this in 098. Well, not the complex fraction part, but the common denominator part. So we'll have B and 3A. So now let's write one fraction over another. We'll have negative 3A plus 4B over AB squared. And then we'll have 3A plus B over AB. And now I have one fraction over another fraction. So now I can do skin over guts. So we're going to do skin, but we're not going to multiply it out. We're just going to rewrite it. So we'll have AB times negative 3A minus 4B. That's your skin. Over your guts. So we'll have AB squared times 3A plus B. Now the only thing that you can reduce is these two right here. So A will go with A, and B will go with one of those. So you're left with, on the top, just the negative 3A minus 4B. And on the bottom, we have B times 3A plus B. And none of that will reduce. Look, a lot of people say, well, we'll just reduce this 3A with this 3A and this B with this B. Why can you not do that? They're groups. If you ever think about doing that, just remember the whole class just saying, they're groups. The only way you can cancel out a group is what? If you have one just like it somewhere else. These are not exactly the same. No. Okay, complex fractions. We're going to talk about the last thing that's going to be on your test on Wednesday is going to be the division of the polynomials. Now, the first one that we've already done, or the first one that we're going to talk about, we've already done. We did this in 4.1 or 2. I can't really remember. But while I have your attention, between now and Wednesday, if you need help, come see me. Go see Corey at the end of the hallway. Go to the tutoring lab. Go through your integrity videos. Whatever it is that you need to do in order to be prepared for this test on Wednesday. This test is going to be a booger. And you're going to have to put some studying time into it. A minimum of 3 hours, I would say. Some of you, not so much. But a lot of you, it's going to take a minimum of 3 hours to get prepared for this test. So just be prepared. Okay, again, the last thing we're going to talk about is polynomials. I don't know if we'll get to talk about all of it, but we're going to talk about enough to where you can do the problems that are on the test. The first thing that we're going to talk about is division of monomials. Now, in 4.1, remember how we looked at our numerator and we factored out anything common and then we reduced? Well, again, you can do that. So, for example, look at your numerator. We can factor out, what, a negative 9x. And when we do that, we're going to have 4x plus 6. Actually, we could have factored out something bigger than that. And I know that because there's a 2 in there, so I guess an 18 will come out. So if we factor out a negative 18x, I'm thinking you're going to get 2x plus 3 over 6x. Now, what we'll reduce is the 6 will go into 18 3 times, so you get a negative 3, and the x's will cancel out. And so you're going to get negative 3 times 2x plus 3. And that's reduced. Because remember in I think it was 4.1 when we were talking about reducing fractions, you factor first, and then you reduce where you can. And that's exactly what I just did. I factored that numerator, and then I reduced where I could. Well, in your upper level math, this is what we look at. If you have a monomial in the denominator, if you have one term in the denominator, you can reduce, if and only if, you can reduce every single term in the problem. So for example, this 6 will go into this negative 36 negative 6 times, and this 54 9 times. If it did not go into both of those, I couldn't reduce it at all. Okay? This x will cancel one of those and that one. So at this point, what I have is negative 6x plus 9. Well, you can see that that will reduce even farther by taking a negative 3 out. Okay. So, one more time. Watch this. Since I have a monomial in the denominator, if you can reduce all the terms in your problem by the exact same number, if not, it won't reduce. Okay? So watch this. 8 will go into itself one time. 8 will go into 45 times, and 8 will go into 72 9 times. So I could reduce every term by 8. If not, you can't reduce it all. Okay? I can take an x squared out of the denominator, and I can take an x squared out of that x to the 4th, and I can take an x squared out of that x to the 5th, reducing all your exponents by 2. I can also reduce by y. 1y is going to leave me with y to the 4th here, and y to the 6th here. So everything in the denominator reduced, and on top I have 5x squared y to the 4th plus 9x to the 3rd y to the 6th. Now, this will factor one more time. Do you see what will come out? Good. X squared and a y to the 4th. So we'll have 5 plus 9xy squared. Again, if you want to do like what we did in 4.1, factor then reduce, you're going to get the exact same answer. Or you can reduce and then factor. Either way, you're going to get the exact same answer. Word of advice, this only works if you have a monomial. And that monomial on the denominator will go into everything in the numerator. Okay, if not, you cannot reduce that. All right. So now, we're going to talk about long division. Do you remember 3rd grade long division? Do you remember 3 into something like 654? And I don't even know if that'll go, but we'll try it. What was the first thing that you would do? Yeah. Let's change this to an 8. 3 will go into 8 how many times? And multiply around, and then subtract and bring down, right? So, first thing that you're going to now do is start all over, actually. 3 will go into 25, 8 times, multiply around, subtract, bring down. Okay? When my little girl was in 3rd grade, and she was actually learning how to do this, her teacher taught her a wonderful thing. It's daddy, mother, sister, brother. Daddy's for division, mother's for multiplication, sisters for subtraction, and brothers for bring down. Divide, multiply, subtract, bring down. And we're going to take that into algebra. Okay? We're going to take that into algebra. So what you're going to do is you're going to set up a basic long division problem, and then you're going to divide first term of the quotient, which is 1 on the outside, by the first term of your dividend, which is 1 on the inside. And that's exactly what we did, 3 into 8. Now what you're going to do is you're going to multiply. This is what's different. The entire divisor, what we put up top, times the whole entire quotient, or vice versa. Subtract, bring down, and repeat. Daddy, mother, sister, brother. You got to go through all 4 of them. Daddy, mother, sister, brother. All right, so watch. We're going to set up a long division problem. This is going to go on the outside. That's your divisor. And then this is going to go on the inside. That's your dividend. 4x to the 3rd minus x squared minus 2x plus 6. Word of caution, does anybody remember from 098? When you're setting these problems up, you cannot skip an exponent. You've got to have a placeholder for every single exponent. So here we have to the 3rd, to the 2nd, to the 1st, and then 0, so we're good. But look here. We're missing a bunch. So when we set that one up On the outside, you're going to have x plus 2 because you're not missing anything. But on the inside, you're going to have x to the 4th, 0x to the 3rd. Remember this from 098? 0x squared, 0x, and then minus your 16. Okay? You cannot skip exponents. That's the first thing you're going to look for in a division problem. Okay. So, step number 1 complete. Step number 1, set up a basic long division problem. Arrange both of these in descending order and make sure you don't skip any exponents. Step number 2, watch. You're going to find the first term of the quotient by dividing the first term of the dividend by the first term of the divisor. What does that mean? First term by first term. Look, watch. You're going to take this first term, x, and you're going to divide it into 4x to the 3rd. So if I divide 4x to the 3rd by x, what do I get? 4x squared. And that's going to go up top. 4x to the 3rd divided by x. We did this in 4.1. Remember, that's just going to cancel out to x squared, so you get 4x squared. Okay, we did that in 4.1. Alright, so now we got to multiply around. When you multiply, look at your steps. When you multiply, you're going to multiply the entire divisor by the term of the quotient found. So watch. You've got to multiply 4x squared times the whole entire divisor of x minus 2. That's the distributive property. So you're going to multiply 4x squared times x minus 2, distributive property. 4x squared times x is going to be 4x to the 3rd. 4x squared times negative 2 is negative 8x squared. Distributive property. Alright, so we divide, multiply. That's 4x cubed. Now you're going to subtract. What happens when you do 4x to the 3rd minus 4x to the 3rd? And that should always happen. That's how you know you're on the right track. That's how you know you did it right, if they cancel out. Alright? Watch this. This is where it gets tricky. This minus sign goes to both of these. Don't forget that. Okay? So you're going to have negative x squared minus a negative 8x squared. Think for a second and see if you can figure that out. Negative 1x squared minus a negative 8x squared. So what are you going to get? Positive 7x squared. You have negative 1x squared minus a negative 8x squared. We all know that this goes to plus. So you're going to get a positive 7x squared. So you divide, multiply, subtract, and what's the last step? Bring down. So we're going to have negative 2x. And then start all over. Start all over. X, first term, into first term. So x into 7x squared, what do you get? 7x. Positive 7x. We need a sign there. What's the next step? We just divided. What's the next one? Multiply. So we're going to take this 7x that we just wrote up here, and we're going to multiply distributive property times x minus 2. So 7x times x minus 2. What are you going to get? Very good. And then we're going to subtract. 7x squared minus 7x squared will cancel out. That's how I know I'm on the right track. In your calculator, if it will help, negative 2x minus a negative 14x. Or negative 2 minus a negative 14. What are you going to get? 12x. So we divide, multiply, subtract. Next step, bring down. Take that 6 and bring it down. And I got to go one more time because I don't have anything else to bring down, right? One more time. What do you get when you divide 12x by x? Plus 12. So there's your division. Next step, multiply. 12 times this whole, 12 times this whole entire group. Distributed property, 12 times x minus 2. 12 times x is 12x. And 12 times negative 2 is negative 24. Subtract. 12x's cancel out. Don't take that for granted. Make sure you check your work. 6 minus a negative 24. Put it in your calculator if you need to. 6 minus negative 24 is going to be 30. Calculator, 6 minus negative 24. 6 plus 24, basically. You are going to get 30. So, on your test, this is what I'm going to say. I'm going to ask you to tell me the quotient and the remainder. What's the quotient? Good. That's your quotient. That's what we wrote on top. What's your remainder? If you want to put 30 over x minus 2, you can, but it's not necessary. So your quotient is up here, and here's your remainder. Just like third grade division. Quotient and remainder. Okay. I'm out of time. So, your test is Wednesday, and I'll just go ahead and tell you your study guide. On page 216, you should be able to do everything through number 28. So everything on page 216, everything through number 28. Okay, 1 through 9 and then 11 through 28. And then page 218, you should be able to go through number 15. And we'll pick the rest of it up on our next test. Please study. Minimum of 3 hours. If you need me, you know where my office is. Corey's down at the end of the hallway. Tutoring lab, library, get together, help each other. Please study.